Welcome to the Total Brake Job, brought to you by Win here. This video will show you how to measure and correct rotor runout. Measuring rotor runout only takes about a minute when assembling new brakes. Runout is defined as the amount of lateral or side-to-side movement of the brake rotor as it rotates 360 degrees. The specification is usually referred to as total indicated runout. Total indicated runout is defined as runout measured on the vehicle or installed runout. Total indicated runout includes all factors that can influence the amount of runout. Runout can be in the hub flange, the brake rotor, or it can be caused by improper wheel nut torque. All of these factors add up to give the rotor's total indicated runout. The average allowable total indicated runout specification for most late model vehicles is 2/1000 of an inch or 0.05 millimeters. This is the maximum allowed. Runout generally does not cause pulsation. Runout causes thickness variation that leads to pulsation. Thickness variation is the main cause of pulsation. Let's say the vehicle had 0.03 of an inch or 0.076 millimeters of total indicated runout when measured at the outside face of the rotor. If this vehicle is riding on 205/55 R16 tires, in 1 mile, 1.6 kilometers, the high spot with 0.03 of an inch, 0.076 millimeters of runout goes past the brake pads about 836 times. Over 6,000 miles or 10,000 kilometers, that spot on the brake rotor will go past the brake pads more than 5 million times. Every time the spot passes the brake pads, a little bit of the brake pad material is removed. Over 5 million revolutions, enough material is deposited on the brake rotor to create a thickness variation that can be felt by the driver as a brake pedal pulsation. Correcting runout is imperative to performing a complete brake job. If you'll be machining the brake rotor, mark the brake rotor and wheel hub for reassembly. Marking its current location will help prevent any runout caused by stacking tolerances. It's extremely important to remove any rust or corrosion from the hub flange face. We recommend using an abrasive pad and a hub cleaning tool for cleaning around the wheel studs. You should never remove more material than needed or produce sparks while cleaning the hub face. Be sure both the inboard and outboard mounting surfaces are free of rust and debris prior to machining or reusing the rotor. To check runout, mount the dial indicator to a fixed point on the steering knuckle. The needle of the dial indicator should be perpendicular to the brake rotor. Measurements should be taken 1/2 an inch or 13 millimeters from the outer edge of the brake rotor. Lift and release the needle off the brake rotor a couple of times to ensure good contact. Next, find the lowest point in the rotor and set the dial indicator to 0. Rotate the brake rotor 1 full revolution to ensure the dial indicator is still set to 0. Now rotate the brake rotor to find the high spot. This is the total indicated runout. In this case, it is 0.06 of an inch or 0.15 millimeters. Mark the high spot on the brake rotor. Try and reposition the brake rotor 180 degrees on the hub. If repositioning the brake rotor does not bring the runout within the manufacturer's specification, you'll need to install a correction shim. A correction shim can only be used if the runout is 0.07 of an inch, 0.177 millimeters or less. Follow the shim manufacturer's installation instructions. Runout more than 0.07 of an inch, or 0.177 millimeters, indicates you will need to check for debris trapped between the brake rotor and hub. If no debris is present, check the runout on the hub flange and replace as necessary. One of the most important yet overlooked steps is the proper torque of the wheel nuts. Please consult the service manual for the torque specification of your vehicle. Using an impact wrench to tighten the wheel nuts is perfectly acceptable as long as they are not tightened to the full torque specification at this time. We are merely tightening the wheel nuts to about 80% of the final torque value. This is enough to hold the wheels in place until the final torque to the manufacturer's specification with a torque wrench. Turn your impact gun to the lowest possible setting with the torque stick. Never touch the torque stick when tightening, as the torque stick acts much like a tuning fork and uses vibration. Holding or even touching the torque stick while tightening will change the torque value and will over-tighten the wheel nuts. Once the vehicle is on the ground, set your torque wrench to the manufacturer's specification and be sure to always use a star or crisscross pattern when you are tightening the wheel nuts. This presentation is by no means representative of all braking systems or brake problems. This is merely a guide for measuring and correcting rotor runout. Brake components should be installed by a trained technician. Any improper installation of brake components may cause a serious safety issue or an accident. Please consult the appropriate service manual for detailed instructions and specifications.